There's been a lot of talk recently about coding and programmable components in the curriculum. So what is coding?
Coding is writing a set of instructions to instruct a microprocessor or a computer on what to do. You'll use coding for producing applications, for mobile phones, for producing websites, or writing computer software. Coding can take two levels, which will be low level or high level, and no, that's nothing to do with the height above the ground.
So what's a low-level language?
A low-level language is the native language used by a microcontroller. To use it effectively, you need to have a very good knowledge of how the microprocessor works. And it's also very difficult for the programmer to understand what is actually written without writing loads of comments. Because of this, low-level languages are rarely used.
And what's a high-level language?
A high-level language is a language which takes an English-like form, allowing the programmer to easily understand what he's doing to control the microprocessor. The main benefit of a high-level language is that you do not need to have expert knowledge of how the microprocessor works. Here's a program which we have which drives Renbuggy. Here we have an include line which brings in a library of commands which have been pre-written for us. This line we declare Renbuggy and we give it a name and we tell the software what pins it needs to connect to, so when it drives the motors it's driving the right ones. The main part of any program is the main program loop, which is called main for help. Here we have some sections which declare variables. We're using variables to store a commonly used number which we can use many times. Also variables, as their name suggests, you can change those values if you need to. And here we've declared these values of iCircle time, which is the time taken to complete one circle, as being 22 seconds. And I've declared a second variable, iForward time, at 1 second. Now we come down to the actual control of the buggy. We have a stop command, so we make sure that the motors are stationary to begin with. Then we send it a command to drive the buggy left, which we do for 22 seconds. To finish off that circle, we go forward for 1 second. Then we go right for 22 seconds. And then finally, we go forward for a further second and then switch all the motors off. And at the end of that, we should have achieved a figure of 8. So firstly, we use #include, which brings in a library of pre-written software for controlling the buggy. At this point here, we define Renbuggy as a unit and we give it instructions on which pins we need to connect to. This is the main part of the software, and this is the bit which every single C program will run first, which is called main. We have two lines here which we declare two variables, which are iCircle time and iForward time. iCircle time we've defined as the time it takes to go for one complete circle for the buggy, and we've measured this and we have found it to be 22 seconds. Also, to close off the circle, we've gone forward for 1 second, which just creates a useful break. So iForward time we've defined as being 1. Because they're variables, we can change these values throughout the program if we require. So to actually control the buggy, we've got these 6 lines here which give it very simple instructions. Firstly, we want to make sure that the wheels are stationary, so we send it a stop command. Then the next activity we want it to do, we want the buggy to go left, to perform a left circle. And we've measured this to be 22 seconds. And what this line will do here is it takes the value stored in iCircle time, which is 22. So the buggy will go left for 22 seconds. To close that off and to form the small break in the middle of the 8 part, we go forward for 1 second. Then to do the lower or the top part of the 8, we send it a right, so it will perform a right circle for 22 seconds. Again, to finish off its figure of 8, we go forward for 1 more second, and then we tell the buggy finally to stop, which then ceases any further motion, and hopefully we would have drawn a nice figure of 8 with the robot.
So what does the code that we've just looked at do?
First, we instruct the buggy to do a left circle for 22 seconds. And then once it's completed that, it then goes forwards for a second, and then we tell it to do a right circle again for 22 seconds. And then finally forward for another second, and then we tell it to stop. And we should end up with a figure of 8. Now we've started the buggy going, you can see that there's 2 lights on there. One light is quite dim, which is the left motor light, and the second LED is quite bright, which is the right motor light. What this means is that the left motor is travelling slower than the right motor, which is allowing us to make a left turn. Now we're going in the opposite direction of the circle, so now the right-hand motor is going slower and the left-hand motor is going faster, which is allowing us to make a right-hand turn.
So in the next video, we're going to look at how code gets from the screen onto the microcontroller.